All right, hi everybody. Hey, I know that I already attached a PDF of the answer key with all the work on it for the review sheet for tomorrow's test, but I know how helpful it can be sometimes just to hear a few problems explained, even though you have the work there in front of you. So I just kind of picked out an assortment of some different problems that if that's you and you'd like to hear just a few of these explained, this might be helpful for you. Okay, so I chose number 4 on the front here, and it's asking us to find the exact values of the 6 trig functions for each right triangle. I should just mention that when it says to find the exact values, that means that no decimals, okay? So we're going to be writing these all as fractions, and when we do the Pythagorean theorem, if when we take the square root, it's not a perfect square, we're definitely leaving the number underneath the square root symbol. Okay, so for number 4, it's a little bit upside down here, but the hypotenuse is actually side 10. Okay, so we're going to start this by finding all 3 sides. Okay, so we want to make sure we're putting that 10 squared on the other side there by itself. Okay, we could work through this here. I'm just asking at a bare minimum that when you guys are doing the Pythagorean theorem that you at least just show this very first step. Okay, that's good enough. The rest can be done on the calculator, no problem. Okay, all right, so then we're going to add that to the picture, and once we have all 3 sides, then we're just going through, we're doing SOHCAHTOA for these ones down here, and then I set this up purposely so right across from each of these are their reciprocal partners. And at this point, hopefully you guys are all completely comfortable with sort of how that works. I will tell you when you go to do cosine, and remember, here's where this is our angle where the theta symbol is. The 5 is the adjacent, okay? So you might set it up 5/10 initially, but go ahead and reduce that. If the fraction can be reduced, reduce it. Okay, with that said, you cannot reduce a fraction like this one here. You can't take 10 and 75, even though 5 goes into both of those. You cannot reduce this fraction because one of the numbers is not underneath a square root and the other number is. So for something like this, you're just going to leave it as is. Okay, and then here we have square root of 75 over 5 and then flipping it this way. Okay, the other 3 problems in that group, 1 through 3, are really similar to number 4 in how you would go about doing it. Okay, so let's take a look at number 6. Number 6 is asking us strictly just to find angle B in the triangle, so I'm just going to kind of highlight that here. There's angle B. Okay, it looks like they're giving us the opposite leg to angle B. They're also giving us the adjacent leg. Okay, don't be deceived. Remember that side that's opposite your 90-degree angle, that is always the hypotenuse. Okay, so again, when you think of SOHCAHTOA, I need to pick a trig function that's going to incorporate the opposite with the adjacent, and that would be the tangent. Okay, oops, I'm sorry. I wrote that wrong. Okay, after you put tangent, you need to put the angle. Okay, and I don't know the measurement of angle B, so I'm leaving the letter B there. I'm going to set that equal to opposite over adjacent, okay? And this is where when you're finding missing angles, you're going to use that inverse trig button on your calculator. Okay, I do need to see this so I can see this is technically what you guys are typing into your calculator to get your answer. Okay, angles, you can just round those to 1 decimal place would be fine. Okay, so that's where we get the 26.6. All right, the airplane problem for number 9. Let's take a quick look at that. Okay, it's really, really helpful for these problems if you draw a picture. In fact, these problems were requesting that you do that. Okay, so here is an airplane flying along here. We'll say this is the ground right here. It mentions that it's 1,000 feet in the air, so that's going to be this vertical distance here. It says that it is 25,000 feet from the runway, and look closely, as measured on the ground. So that is telling you that this distance along the ground here is 25,000 feet. Okay, and there's no way that this picture that I just drew is drawn to scale at all, but that's okay. It wants to know what is the angle of depression that should be made by the plane to make a smooth landing. So we are looking for this angle down here in the bottom right corner. Okay, we've talked before about how that's the same as this angle that's up here on the outside of the triangle. Okay, and so I'm going to again think through, okay, well, what do I know? I'm going to use this angle. We're given the opposite leg, also given the adjacent leg, so I would want to use tangent of theta, set that equal to opposite over adjacent. Again, we are solving for an angle, so I'm going to do the inverse tangent of both sides. This is going to be, and by the way, when you guys do these airplane problems, these angles should be super small angles. Things somewhere around 1 degree, 2 degrees, nothing higher than 5 degrees. Because honestly, if you've ever been in an airplane, you really don't even realize that you've started descent until you start hearing your ears pop. If even the pilot tilted the nose of the plane down, even just 10 degrees, which might feel like that's not very much, you would most definitely feel that and think that maybe the plane was starting to crash or something. So just keep that in mind with these, that your angles should be really small, definitely under 5 degrees, okay? All right, so let's go ahead and take a look at number 11 and 12. It's first asking you to just draw the angle that's named here, okay? Keep in mind, if the angle is negative, that's when you go clockwise, okay? Every quadrant holds 90 degrees, so you kind of want to say to yourself, okay, if I go here, I've got 90, I don't want to go a full other 90. So if just even on your calculator, you took 121 and said, okay, I've gone 90 degrees, so let's subtract 90 off of that. That tells you how many more degrees you need to travel in here into the third quadrant. Okay, I'm getting 31 degrees, so I'm going to roughly draw it like that. Now, here's where you have to be careful. When you're asked to say what the reference angle is, though, the reference angle is not 31 degrees. The reference angle is always how far your terminal ray is from the nearest x-axis. So if you look at my orange terminal ray in this picture, it is definitely closer to the left side of the x-axis than it is to the right side. And again, these reference angles, they are always positive and they are always acute. That means they're always less than 90 degrees. So I need to figure out what is this gap right in here, okay? So that gap right in there, well, if this was 31 degrees and I know there's 90 degrees in this entire quadrant, then that gap would be 59 degrees, and that's what the reference angle is. Okay, let's try one more here. We're going to sketch a positive 308 degree angle. Now I'm going to go counterclockwise. Okay, I'm going to go 308 degrees. So here I've gone 90, here I've gone 180, here I've gone 270. I need to figure out, okay, how many more degrees do I need to travel? Well, I need to travel an additional 38 degrees here into quadrant 4. Okay, that would be a 308 degree angle. But again, keep in mind, your reference angle is how far your terminal ray is to the nearest side of the x-axis. It's much closer now to the right side of the x-axis than it is to the left. So I need this gap in here. There's a variety of different ways you could get that gap. You could say, look, I know there's 360 degrees in a whole entire triangle. So if I've already gone 308, I just need to figure out what's the difference between 360 and 308, and that's going to give you 52 degrees as being your reference angle. Okay. All right, just a couple more here. For 18, 19, and 20, these were arc length problems. Please keep in mind it's a very simple formula, but it does have some specific requirements. Okay, first and foremost, you cannot use the diameter. You must use the radius. And secondly, the angle that's you plug into the formula, it must be in radians. It cannot be in degrees. Okay, so I chose 19 because they gave us neither of those two things. Okay, they gave us the diameter, so I'm going to immediately cut that in half and say, well, then the radius is 8 inches. And they gave us the angle in degrees, and so I'm going to go ahead and convert that out of degrees and into radians. And it looks like if I do that, I'm getting 2 pi over 3 radians. Okay, so what I have now is I have the radius, I have the angle measurement in radians, So then when I go to use the formula, this is what I'm going to type in. By the way, when you do this, you can now type the pi symbol into your calculator for these arc length problems, and you can just report the answer rounded to 2 decimal places. And you should label the answer whatever the unit of measurement is that the diameter or radius was given to you in the problem. Okay, last couple here. This is asking you to draw a labeled diagram. They give you a point 12, -9. So I'm just going to plot this here. That's the point 12, -9. When you draw your triangle, you always want to draw a perpendicular line from the point always to the x-axis and then connect your point to the origin. This makes your triangle. Okay, if they give you a point like these, you just follow the path of these legs. I went 12 to the right, so that means the horizontal leg's 12. I went vertically down 9, that means that vertical leg there is -9. And then I would just work through doing the Pythagorean theorem, and I think that you can watch or look on the PDF of the answer key to kind of see that this is just getting what the hypotenuse is. The hypotenuse does end up coming out to be 15. Remember, you should always label the hypotenuses in all of these pictures as always being positive. It's only the legs that could be negative, depending on which side of the axis you're on. Okay, past that, you can see on the answer key how I filled in all of those fractions. Okay, and then let's look down at number 25. Okay, now 25, it's similar to 21 and 22, except instead of giving you a point, they're naming a quadrant. So you have to keep in mind that you know what the 4 quadrants are. When it names quadrant 3, you're just going to blindly throw a point there in quadrant 3, and you're going to make a triangle. Always connect it to the x-axis and to the origin. Okay, now they give you that secant is -5/3. Okay, now remember, secant, that's the reciprocal to cosine. So if cosine is adjacent over hypotenuse, then that means secant is hypotenuse over adjacent. So that means this 5 is the hypotenuse, this 3 is the adjacent. So I'm going to label the hypotenuse 5. I should put the theta symbol. It always goes in at the angle closest to the origin. And I'm going to label the adjacent leg 3. But if you look closely at this fraction, you see how the fraction was negative. That means either the hypotenuse is negative or the adjacent leg is negative. And we've said, look, the hypotenuse, it's never, ever negative. And so that means I have to label the adjacent leg as negative. And if you look at the picture, it makes sense that that horizontal leg should be negative because it's laying right over top of the negative side of the x-axis. Okay, so then I keep going here and I do the Pythagorean theorem. I find the missing leg, sorry about that. This comes out to be 4. Okay, now here's the trick though. Even though I got that to be 4, when you come over here and you add the 4 to the picture, ask yourself, do I need to make that 4 a negative based on where this vertical leg is positioned? See how the vertical leg is on the bottom half of the y-axis? Well, that is a reason that I then in my picture need to make that vertical leg a -4, so that when I set up my fraction for tangent, I'm doing opposite. I'm going to do -4 over adjacent -3. So I'm technically just going to say that tangent is +4/3. Okay, hopefully this helps. If you have other additional questions, just reach out to me and I can try to answer those for you as